Okay, so good evening and welcome to today's set colloquium, the title of which is the Undergraduate Science Program at Azim Premji University. It's going to be given by one of our former colleagues at TIFR, Professor Rajaram Nityananda, who is currently at Azim Premji University, Bengaluru. Just a couple of words for those of you who don't know him. I'm sure almost everyone on the call knows him, but nevertheless, let me say a few words about him. Rajaram worked in areas of optics, crystallography, and condensed matter, and astronomy at the National Aerospace Laboratory and Raman Research Institute in Bengaluru before moving to National Center for Radio Astrophysics at TIFR, Tata Institute of Fundamental Research, in 2000. And he retired in the year 2013 as the center director. He has served as editor of Pramana, the Journal of Astrophysics and Astronomy, and Resonance, and took up teaching assignments in physics, astronomy at the pre-PhD, master's, and undergraduate level during this period. After 2014, he has been a full-time member of the School of Arts and Science at the Azim Premji University, as I mentioned, in Bengaluru, and taught in the undergraduate program. So today he is going to kind of give his experiences in teaching, in managing the undergraduate program at Azim Premji University. So over to Rajaram.
Thank you, Dr. Nityananda. Real pleasure to be back and see so many friends. You will notice that I've actually retired. So technically, I'm not at Azim Premji University, but of course, very much in touch. I've given you our postal address in full glory to bring out the fact that it's quite rural. So don't be misled by the Bangalore part. The pin code doesn't even have a 0 in it. Members of the school cycling club told me that they go to Tamil Nadu in the evenings and so on. Okay. So we are in the extreme east of Bangalore. All institutes, including the Tata Institute, have to start in temporary campus while they're building the permanent one. Yeah. So I'm calling this the Yacht Club, which members of TIFR, at least the older ones, would know what that means. That's where TIFR started. But for us, it was a fortunate accident that there was a builder who had built a lot of plots and houses and built a school, but of course there was no one there. So he gave this to us. Initially, we thought for a few years because our campus was coming up, but the way this happened, the university and foundation do not believe in any speed up processes. Every regulation laid down by the government was followed. So it took its own time, but this campus was vacated just a short while back. So the first batch you see, I taught them math methods and physics, and behind them is the most important part, the dining hall. To the left is the residence, and they are facing a large playing field. And to the right are the class and labs, which of course grew by a couple more stories over those 5 years. So I'm calling this the promised land because it was promised, promised, and then it has come. Okay. This picture is taken by my colleague, Sharandeep, at the School of Arts and Sciences. As befits a member of the humanities faculty, it's loaded with symbolism. It's a long shot, like this colloquium will also be, a long view. You can see bright prospects, moving to a new campus, having more facilities, more space, more scale, but also dark clouds like COVID. And I think the one part which is deeply symbolic is that it will always be under construction. I mean, that's been our experience, that things keep evolving. Okay. The context of the undergraduate science program that I'm going to talk about is that, what my maths colleagues would call inclusion maps. So, it's part of a bigger undergraduate program, which is part of the university, which is part of a foundation. And the foundation takes very seriously the fact that it is part of our country. And we will see how this actually works out in practice. So this is the relationship between these entities. A quick summary before we get to the main topic. The foundation is something of an umbrella. It has a philanthropy wing, which really is dedicated to funding efforts, mostly non-governmental, in which really deal with some of the most disadvantaged people who are completely neglected and so on. Various areas, could be disabled, could be construction workers. So that's the kind of thing they fund. But I would say a major part of the activities of the foundation, which is linked to the university, is what is called the field. So this is built up over 20 years. The idea is to engage with the government school system, because that's where the majority of students were going 20 years ago and even today, I think. So after conducting sort of visiting programs, the model now is to have a permanent district institute. So people build up relationships over decades with the teachers, with the administrators, and in 48 districts. And in many of them, there is also half a dozen of them, perhaps, there's even a model school. And there are some 1,400 people involved in this activity. And then about halfway in this decade, in this 20 years, the university started. And the initial impetus was because it was felt that not enough people are entering the areas which would serve the interests of the foundation. So you can see education, development, policy and governance, and then centers for continuing education, training, knowledge resource centers, and so on. So that's the university. And these are entirely postgraduate courses, and they're open to any graduate. It's kind of interesting, right? And in the initial years, we were co-located. So there was a lot of give and take between the undergraduate and the postgraduate faculty. And then, of course, we got geographically separated. So this is the overall scale of the university today, okay? And please note the ratio of faculty to students. It's still very, very large. Right? In any case, the School of Arts and Sciences dates from 2015, and that's also the time that I had a chance to move there. I have to say, I moved there as a spouse, right? Yeah. But in any case, they found a place for me and we had a great time. And the initial undergraduate degrees offered were in biology, physics, economics, and a combined humanities consisting of these three entities in brackets. And then a few years later, mathematics started. A 4-year BSc B.Ed started. So the idea is that someone joins for a BSc B.Ed, say physics, they get pretty much the same physics courses, but in addition, they get a very solid background in education, field experience, and so on. And of course, the university is very well placed to give them field experience in schools. And then we think of the school as undergraduate, but the economists didn't think so. So they've also created a master's program. And I find the economists very interesting. For example, every year they publish a survey of the state of working India, which says a lot of things about employment and so on. But since my primary concern is science, in brackets, I have some of the things which are still on the anvil. This is what I was alluding to when I said we are always under construction. 4-year program in all the majors, along the lines laid out by the NEP. Chemistry, certainly, right? It's just that we couldn't do everything to start with, and perhaps even social science. And the brackets around the 3 humanities items also connote the fact that in future you could major in one of them as well. Okay. So now zeroing in on the undergraduate program, the first thing which does influence the student body and so on, and also tells you a little bit about the university, where it might differ from others, it is not for profit. And actually, it is designed for loss. We've been told this figure. It may evolve a little bit, but typically the university spends some multiple, 3 or 4, on each student compared to even the full fee. Okay, and naturally this comes from the endowment which drives the foundation, or rather the interest of the endowment. I guess they don't want the endowment itself to diminish, right? And diversity is taken very seriously in the admissions. So there are scholarships which are entirely need-based. So once the student crosses the threshold of our entrance process, and the entrance process itself involves certainly the discipline, but also other aspects, whether the student would be comfortable or interested in a fully residential program, for example, right? So you might be living just in the housing outside the university, but you would still have to be there all the time, because a lot of the things take place outside the classroom, including the science. One thing which is taken very seriously, and at least for curricular space, in some sense, it reduces what you might expect for a science program. So we wouldn't claim that we have the same amount of curricular space for science as maybe other programs, is that there's a very strong common curriculum. Okay. So I've written 3 out of, of course, 4 parts is disciplinary, then we'll see what that is. It also has to do with diversity, in the sense you're bringing in students with a wide range of backgrounds, and you would like to reinforce a lot of the basics. So the famous 3 R's, reading, writing, and reasoning. Okay. And recently a 4th R is being discussed, which might even be the R programming language, actually. I did teach 1 course on that to a bunch of people. But in any case, I think the feeling is that in this day and age, why not kick off things? And of course, it certainly helped the disciplines as well, to have the students comfortable with these things. And the initial year, of course, which would work much better than a 4-year program, is to help people settle down, level the playing field, so on, because you don't want to be left behind right at the beginning. So there are, but even with the 3-year program, there's a strong effort. There's a language center, because certainly, incidentally, it's not necessarily people from the most disadvantaged educational backgrounds who have problems with language. There are people who are very fluent in the spoken language, but when it comes to the kind of writing which is demanded by the common curriculum and so on, I think pretty much everyone has to buckle down to it. Maths centers, I'll say a little more about that later. And if you have admitted students, and if some of them do have gaps, we do try to bridge those gaps, perhaps even before they come in a couple of weeks or in the breaks. And one important part of the common curriculum, perhaps almost half of it, is something called Understanding India. And that is very uncommon, right? To actually devote, I think initially it was 5 courses, and now it's 4. Discuss, okay, it's all very nice to say what India is geographically and do a little bit of plate tectonics and so on. But by the time you come to ask, who is an Indian and so on, the classroom can get pretty lively. And these issues are faced by our students and our faculty. So this is considered quite important. And the students also warm to it after a while. Right? One of the teachers took the students to a garbage dump, because that's also understanding India, right? And this does include a short residence in one of the breaks in one of the field institutes. So that's one of the linkages. And certainly you go somewhere to Rajasthan, see what a real government school is like, what the parents are like, and so on. The students come back telling us that it will. And of course, the faculty are encouraged to go along with that. So this diversity is also built in to the notion of the outcomes you're looking for. So it's not automatically assumed that everyone who enters a physics program is going to do an MSc, a PhD, and join a research institute or a lab or something like that, right? So once one has dealt with the core, there are different, they're not formally called streams, but to cater to the range of students, there's a range of electives. We will see supporting courses when we go to the curricula. And there's an honors program for those who would like an experience of some research at the undergraduate level. And interestingly, even right from the beginning, there were minors in education and development, the topics of the postgraduate programs. And many students actually got more interested in the minor than in the major, and they moved we didn't ask them to move to the postgraduate programs of the university, but they were certainly exposed to these themes, but now this is broadened. So you will have something called data and society, or environment and energy, or things like that. Okay, so interdisciplinary minors, and now that has become part of the common curriculum. So everyone will have a major. They will have these supporting courses, which you could configure into a minor, but a disciplinary minor. But you will also have, so all this does impinge on the science program. So if someone really wants to focus on science from day one, right, this may not be the best place. But if someone wants to explore different options, then this may be a good place. Just a word on how all this pans out on the ground. Yes, one innovation was creative expressions, which is normally called extracurricular activities, you know, football, or except that it's part of the core. Everyone has to do something, and it's credited. You have to pass. So of course, there's an interesting problem of how do you pass football or yoga or something, frisbee or something like that. But the idea is that it's embodied. You know, it's not purely using your intellect. We get very interesting choices here. I already mentioned the experience in the field. And for the faculty, we are encouraged. In the initial years, when the numbers were smaller, all of us could do it. Now it may be a little more difficult to, even if you're not, you know, a resident faculty, you could spend one or more nights, and that way really interact with the students, including some 10 of them who are allotted to each one of you, where you mentor them, and then you kind of keep track. You're the kind of first responder in case, you know, one of them has some difficulties and so on. Of course, after that, there are other systems to help them. But I have to say, having done this mentorship for some years, when it gets really difficult, you go to the counselors, sorry for the misspelling, and a group of people called resident mentors. I mean, they are much more than wardens, okay? They really, in fact, they end up knowing all the students, and the students end up knowing them. I think a huge amount of student support does take place. And we also found it's necessary. I mean, these are at a very critical age, and they're being tossed into a completely new environment. A lot of activities, some in the discipline, you have physics lab, maths lab, and so on, some cutting across disciplines. I would say astronomy has been very popular, and it's by no means restricted to physics or maths people. And there's a lot of lively discussion of social issues, of gender, so on. And these are largely student run. And over the years, the students have set up committees and they run many things like the menu and so on. So this is the overall picture in which you have to embed the science program. So before coming to the individual disciplines, I can say that there are some common features in the design. And that's not a coincidence. So we were all thrown together in the older campus. We didn't have separate offices. And faculty meetings were essentially everyone meeting everyone. So, so some of what I'm putting down here might even apply beyond science, but certainly within physics, maths, biology, a strong core. Say if you had 11 courses in the core, maybe 8 of them might be a strong core. But also keeping in mind that one size doesn't fit all. You can have multiple paths. Okay? And I'm sure everyone tried to bring out connections within the major so that students didn't have a very fragmented view, and even across majors. Right? I've already mentioned the efforts to make sure that we did not leave students behind early in their entry. And there's a very serious effort, certainly in physics and biology, not to purely have theory. And in physics, that's a very great temptation, right? Students come in having read the brief history of time, and then you take them to the lab. But it's not a cookbook lab. It's a very interesting lab, in fact. It has things like laser cutters, 3D printers, lathes, and so on. And that's no thanks to me. Those of you who know me would know that there must be someone else, colleagues, who have built up this tradition of students working on building things for themselves and Even a lot of the apparatus they use is fabricated by the faculty. So that's an interesting model. And of course, physics can claim that they did help the biologists also set up their very nice facilities. Interestingly, what's a lab in mathematics? Okay. I realize I'm at least virtually in TIFR, where my colleagues were at pains to tell me that mathematics is not a science. But nevertheless, it's part of this lecture. And their lab is something called inquiry-based learning, which I didn't know much about until they told me about it. It's a very, very hard on the students and very hard on the teachers. So initially, they struggle to, but it's probably necessary given the kind of maths which is more plug and play, which people are exposed to. Maths colleagues decided to take this hard path, and we will see how they did it. Assessment, which is quite important, tends to be distributed throughout the semester. It tends to be varied also. I myself was very conservative and didn't give many projects. But when I started doing that, I realized that students really warm to it. They don't have to be research projects. I mean, there could be a few topics where they can go deeper, make a presentation. It takes up valuable time and space, but I have to say that they really take to it, and maybe it helps their appreciation even of the core. So these are some of the common features of all the units in the science program. Now, let's again look at the general life cycle of a course, because people entering often ask, do you have a lot of freedom to design courses? So you can decide that after I take you through this life cycle. So yes, you go ahead and you design a course. Okay. The first thing is that, and shock for me as well, that you produce a course document. And the format is dictated by a lot of education theory. So I think colleagues at the Homi Bhabha Center will be very happy to see that you are requested to give the course objectives, to classify them into whether they are purely procedural or conceptual, and so on. How are you going to achieve these objectives? How are you going to assess them? So quite a rigorous course document, but it's discussed in the group informally. You show it to your colleagues, and some of them probably understand these documents better than others. But then within the school itself, before it goes to the next level in the university, people look at it, you get feedback. So that's a curriculum review committee. Then there's the curriculum and pedagogy committee, which puts its stamp. And ultimately, of course, it goes to the academic council, but that's more of a formality. But the CPC is not a formality. They will come back and tell you, are you sure that mathematics is really a language? Shouldn't you be saying something else? And so on. So a fairly serious process, but that's not the end. We're all encouraged to get informal feedback, and it certainly saved me in the first few courses I taught. You realize that you have to make some serious mid-course corrections, right? And there is formal feedback at the end, which is collated and shared with the instructor. In turn, the instructor also records a course report, right? What worked, what didn't. So this is a valuable body. So someone comes in to teach a course, they have access to all this material, and it certainly helps. And then every now and then in your classroom, you will have a visitor from something called the teaching learning group, but it's not an external group. It's made up of our own colleagues. So, I might be sitting in someone else's lecture and making some notes and giving some feedback, but this is very much an individual level. It's kind of colleague to colleague. And we have to acknowledge that all of us are better critics than, right? So when you're teaching, maybe very difficult to see what are the things you're missing, but you sit in a colleague's thing, you can say, yes, okay, these students seem to be disengaged, or even more drastic things like these are on their mobile phones and so on. So it really helps. The TLG really helps. It's across majors. So I could have a humanities person sitting, and then they would really look at bigger issues, right? And then at the end of the semester, the whole group gets together. At least it used to when it was measured in the 10s and 20s. And now we are 70, so not that clear. But still interesting that these are all reviewed. So much for the general aspects of the science program, which are, of course, common with some of the other programs as well. So now I think I'm going to show you some curricula. And the next 6 slides are entirely plagiarized because by a fortunate coincidence, soon after I agreed to give this colloquium, colleagues, I was not attending these meetings by that time, I retired, but colleagues in the majors actually created presentations for the bigger group, just to kind of looking back over the last 5 years, right? And they were kind enough to share it with me. So I'll be showing you some of the curricula. And I'll also be, and that's a subjective choice I made to pick out something from the presentation, which is like a highlight. I know that it cannot really be representative, but something I felt will give you a flavor of what's going on. So let's start with biology. Okay, I think I'll just leave it. I will not read it out, but I can keep talking to you, and maybe this will trigger some of the discussion which could take place, of course, during the seminar if it's pressing. Otherwise, at the end. So you can certainly see that if someone took biology because they were going to avoid calculus or computer programming or chemistry or physics, well, they have a surprise coming in. So our biology colleagues take these things pretty seriously. In fact, I was pressed into service to try and explain the concept of free energy in 2 lectures, which if you try it is quite a challenge. But biologists thrive on free energy. I mean, both in the classroom and, of course, as living beings also. Okay. So this gives you a little more of feel for the honors, and we'll see this again in the other disciplines, right? The honors gives you an extra 12 credits, right? So the ratio of 3/7 I gave you was 36 in the common curriculum, which we're not looking at, divided by 84. So your standard pathway in all the disciplines would be these 48 credits, but typically they further break up into the core and the supporting courses. Okay, and there's some more flexibility here, but honors, which gives you an extra 12 credits, half of which are for your project and a thesis, but half of which are for more advanced courses. And the biologists have decided that they will concentrate on certain areas. Okay, it doesn't have to be that way in the other majors. In the other majors, it tends more to be individual faculty pursuing very diverse themes in the honors projects. But here they've decided to close ranks. Of course, these are still large areas, but partitioned into ecology environment, which is certainly a strong point in the faculty, and this other side to it. Okay. So that's biology, and it's really hard to pick out from all the marvelous things that they do. So I just picked out this slide, right, which tells you that the faculty and the courses are quite eclectic, and the students do get a varied experience. I have to say that, like many physicists, I do suffer from a certain amount of biology envy. When the students do come in, within a few months, they are learning about exciting things. It could be CRISPR. And certainly very exciting things are happening in ecology, environment, and so on. And within the same few months, we have maybe dropping bodies or immersing them in liquid or something like that, right, in physics. But there isn't any choice. That's the way physics is constructed. Okay. So this is biology, and I can try and answer more about it, or I can call a friend if necessary. So let me move to mathematics. And the first thing you will notice is that we believe in diversity even in the way a slide contains the information about the courses. Okay. So I mentioned the IBL, right? So these courses, Introduction to Mathematical Thinking 1 and 2, which of course they have content. It could be discrete mathematics, it could be calculus. And I mean, this is quite apart from the formal calculus course. Right? But here the emphasis would be on sort of their getting used to the more mathematical way of doing things, appreciating what a formal proof is, what is acceptable, what is not, the basic tools of logic and so on. And this is actually hard. It's quite hard. In fact, the classes are small, but the maths faculty even decided to split them further so that they could give more attention. And they're really building for the future. I mean, investment in these two courses hopefully will repay itself when they come to the later courses, which are taught in a more conventional manner. Given the constraints, you cannot do everything, right? But some of it can be made up in the electives, right? And that also takes care of different interests of students. Some may be wanting to go more deeper into the purer aspect of mathematics, some wanting to go into maybe computers, statistics, and so on, right? You can see electives, you can see supporting. And I mentioned the BSc B.Ed. Incidentally, mathematics has not yet graduated a batch. So the first batch is just entering BSc B.Ed. So all this is still in the future, right? And of course, in the School of Education, there have been people who are specialized. For example, Rakhi Banerjee of HPCSE is very much with us. And so these would be taken very seriously when students do the BSc B.Ed in mathematics. Now, again, I have just somewhat arbitrarily, subjectively picked out one slide from a long presentation by maths colleagues, just to give you a flavor, right? I'm not sure what the one on the left is, but in the middle, you can see a kind of outreach, but it's really in reach, because mathematics really needs to reach out even within the same institution. So you can see one of the students explaining perhaps a two-dimensional symmetry to a humanities colleague whose shirt also has some two-dimensional symmetry, I noticed. And likewise, here there's a nice demonstration. So a lot of these events do occur, and some of them internal, like Pi Day and so on. So I was asked to give a talk on Pi Day, and I chose the icosahedron because many years ago, since NAL was mentioned, I was asked to tile an icosahedron so that a dome could be put up over a radar dish, one of my very treasured memories from my PhD days. But in any case, these are the many dimensions which the maths colleagues have to cope with: filling gaps, overcoming fear, which is a very genuine thing, even amongst those who opt for mathematics, right? The IBL, which is a very demanding methodology. And in addition, since we have these schools in the foundation, there are already pilot efforts to link up with students there and teachers there. And students from economics or physics who need some gaps filled in their mathematics, there is the Math Center, TMC, so that's what it stands for, not what you might think, right? And as if all this was not enough, right? It's a small but lively maths group, I think now 5. And I personally have benefited from the fact that they decided to have group seminars. So it gave me a chance to learn about the interests, diverse interests, these topics. Of course, topological data analysis is now quite an applied field. People are using it in many fields, but these two certainly are as pure as it gets. And certainly I enjoyed it, and they certainly gave very, very insightful courses. So this is something that all academic groups face. They would like to keep their research interests alive in whatever time is available, right? And each group does it in its own way. So that brings me to physics, right? Which I've kept for the last. So again, you'll see a different format for the curriculum. I have to confess, it's a very staid format compared to the lively ones of the maths and biology. And there's not much scope for originality in the core. In fact, there is a legend, I will suppress the name of the person in the Indian Institute of Science many, many decades ago, who looked at the courses for the students and said, why so much mechanics? You know, mechanics, classical mechanics, statistical mechanics, quantum mechanics. But that's the way physics goes, right? So they have core courses, you have their prerequisites, and you see the supportive courses. Incidentally, all these things have evolved, okay, and will evolve. Okay. Broadly speaking, we do see the students, we have not made as strong tracks as the biologists have, but we do see that some are more inclined towards theory and more maybe abstract areas of physics, and some of them actually thrive in the electronics lab. And it's not just, again, a cookbook lab. Certainly, some of my mentees told me that some of their best moments was when the entire electronics course was building something which actually worked and was exhibited to the entire group after that. But again, general biology is available, chemistry is available. Okay, even now, before the full chemistry major launches, here are some typical electives which you can see, right? Different prerequisites. In fact, astronomy has been taught by one of my colleagues, and he has made it a 0 prerequisites course. So you get a few people trained from elsewhere. Advanced electronics is going right now. One of my mentees, who's a biologist, is studying a lot of digital electronics, right? She resisted a bit, but I think she's enjoying it now. And honors projects, I actually know a little more about the physics scene than the other disciplines, but they tend to be quite diverse. In fact, some of the physics honors projects have actually been guided by maths faculty. I remember one where there's a conjecture by Maxwell on the number of maxima and minima of the potential in endpoint charges, which is still unsolved, I believe. And this, I learned about it from that honors project. So again, you know, picking something not as representative, but just as something that might look interesting from the physics group. And again, I can hardly claim any credit for it. Just to make that clear, I have not said much about how the challenges of online learning and so on were addressed. I will not say that. But labs, what does one do about that? You know, because every physics course had a lab component, and in fact, you wouldn't have seen a separate lab except for maybe electronics or so on. In the case of thermal physics, which I taught once, along with a colleague who was very strong in soft condensed matter, and she came up with some marvelous experiments which livened up the thermal physics course. So here, maybe I'm revealing my optics bias. I mean, this is very primitive if you think of it as the lab at Azim Premji University. But the whole idea is to make lots of copies of it and send it out. Okay, so that actually happened. So if the students thought that, you know, because of the pandemic, they were going to be exempted from experimental work, that did not happen. They did the experiments, they videoed them. I mean, some of them were very enterprising. And who knows? I mean, let's remember that fundamental discoveries in optics were made during another pandemic by Isaac Newton. So maybe sending out these kits. And as I said, I've been biased towards optics, but the same thing has happened in electricity and magnetism, and electronics, and thermal physics. So I think this is something which took a lot of hard work. And again, from the feedback from my mentees and so on, it's really kept their interest alive. And that's so important. So this is my brief journey through the majors and the curricula and some highlights, just to give you a flavor. Hopefully it will generate some discussion and perhaps more important, even later interaction with colleagues there, if anyone is interested. So to conclude, I do have to make some qualifications, right? And I think some of the words which you find in quotes like reflections, learnings, and so on, are words which were added to my vocabulary after joining the Azim Premji University. The first caveat is that this is not an official presentation. One doesn't become an expert in undergraduate education by just spending, 6 years there after spending 12 years in TIFR and 24 years RRI. I've juggled the numbers a bit to make it a geometric series. So rather, I'm really one of you who ventured into this world, and I've come back to tell the tale. Okay. I haven't had said much about the pandemic response, the challenges of online teaching, apart from the labs, and things which are coming up, like the postgraduate and undergraduate faculty and students will all mix and mingle. And I think that's part of the design, but and there will be new campuses. If you're looking on the time scale of a decade, a Bhopal campus is already underway. But these will typically be state universities, but certainly they will all be under the same umbrella. So one thing I can say is that for faculty, it's a very rich experience, different for each person. And since I have a little time, maybe I will just pick out two of my own, even though this is statistics of one, right? So it's not really meant to be generalized. So I certainly remember soon after landing, I thought I'd put radio astronomy and all the concerns about the power radiated by mobile phones and so on behind. And then it turned out there was a mild student protest from the postgraduate students. They'd been moved to a hostel, and if they looked out of their window, they saw, a tower with a huge number of, radiating things. So of course, a professional was hired to measure the power, but someone had to translate it into terms which would reassure these students. So I was given that task. And what finally worked is that, yes, you are being cooked to a mild extent by these mobile. You can't avoid that. But you're being cooked much more by the internet routers, which are in your own building. And and no one's going to take those off. So we have just 3 batches who have graduated. I won't count 2021. They've just literally a few days ago submitted their honors projects under very difficult conditions, I should add. Okay. The previous batches seem to have gone far and wide. So in physics again, where I'm more competent to speak, we have seen them going to conventional MSc, say Bangalore University or IIT Roorkee, or integrated PhD programs like maybe SN Bose. But quite a few have ventured beyond our shores. Not necessarily, the quote unquote topplers. And that was a surprise. In fact, I have to confess I was a little apprehensive. One of our students who was very sincere, and I certainly think he had the potential, but he went to the same school called Sapienza where Enrico Fermi went, which is clearly rather rigorous, but he seems to be doing well. Okay. One of the physics students did a project on oscillations in a biological system, and he seems to have liked the biology, so he's doing some fairly rigorous master's program in France on that, and so on. So quite a lot of diversity, and some, as I said, have gone into education or development. So what are we? Still too early to say. We're just talking of 5 years of an undergraduate program. These are all the questions which are often raised, right? So I would like to conclude with a bottom line. Okay, the bottom line will be going back to the national scale, and you will also see the astrophysicist in me coming up, because I'll be giving you some very, very rough numbers, but the logarithms of the numbers will be okay, but that is really the lesson. Okay, so let me tell you what these numbers are. Let me see if my cursor is visible. Yes. So this 20 million, right, is the number of kids who will be entering our school system every year. Okay, you can check. And if you accumulate them over 10 years in a school, right, this is what you will get, some 200 million. Okay, and I did cross-check in the internet that these numbers are not crazy. Okay? And then you need teachers, surely, to look after them. But I mean, this may look like a very favorable ratio of 20 to 1, but it isn't really if you look at all the pressures on school teachers, right? And the fact that they don't have to be in there. They have to prepare, they have to do election duty, so on. So I don't think this is an unreasonable number. Right? Then you can decide. So we're talking of 10 million here. But of course, teachers retire and they have to be replaced. Maybe this is a generous number. You could make it 500,000 if you like. Right? If each one resided for 20 years, you have to produce so many teachers. And these are the kind of teachers you would like to interest all our young people. Now, I think the numbers match up, right? But if it's in terms of surely so much more to be done in terms of equipping them with everything that they need to carry out this task, and that task is absolutely vital. Right? And coming to undergraduate science, let's remember that to teach in the 12th standard, 11th and 12th, you now need a master's degree and an education degree. Right? That's the kind of combination you need. So I've just again knocked off a factor of 10. So are we producing these many MSc MAds or MSc BEds? If you ask me how many our university will produce at full scale, we don't have MSc BEds yet, but if we did, I mean, it would be a drop compared to this. Right? So I just like to leave you with a sense of the kind of scale and the numbers in education. And certainly you want, you don't want to just fill the numbers. You want to deliver. And what you have to deliver, again, is changing very rapidly. Right? So this is the challenge of all programs, and in particular, the program that I have been talking to you about. So thank you, and I hope this provoked
Thank you.
questions.
Yeah, thank you, Rajaram. Thank you very much. It was a very, very interesting talk, very nice one. I'm sure there will be many questions, opening up the areas probably you didn't cover, but I'm sure it will lead to further discussion. And so anyone on the Zoom platform would like to ask questions, please go ahead.
Maybe, can I ask a question?
Yeah, please, sir. Please go ahead.
Okay. Well, first of all, Rajaram, it's always such a privilege and joy to hear you. Thank you for a really beautiful talk given in your customary elegant way. You know TIFR very well. You know the Homi Bhabha Science Center. You have a sort of unique perspective for us because you know us and you know Azim Premji and so on. How can an institution like ours, not of course specifically HBCSC, but also just more generally TIFR, engage? As you brought out in your last slide, the problem is gigantic. Azim Premji is at the forefront. What can we do? What are your thoughts?
Okay, I may not have something very focused to respond to this, but it's certainly an important question. Incidentally, the School of Education has, I mentioned Raki, but there are others who are alumni of HBCSE who are with us. And so certainly there's a certain amount. And since, as you say, I have sat in various fora related to HBCSE, I've been talking to see what kind of activities. So I thought the very first step is, a wider awareness of what's going on. And I hope this triggers some of that. Incidentally, almost everything I said is public domain, right? There's nothing secret about it. But, in an age of information overload, I think the information has to reach the people to whom it's meaningful. Okay. So perhaps rather than give some very global solution, I think it's going to be individuals who have the knack or the interest, right? After all, that's the way HBCSE started, right? I mean, Professor Udgaonkar, was fully capable of looking at, the Reggie trajectories and the Coulomb potential or something like that, but he decided to, right? So to individuals, I think, yes, there are possibilities, but maybe even more systematically, I think we have a lot to learn from HBCSE because HBCSE has a long history in science education. I think there have already been exchanges a little bit. We are in touch. Some of my colleagues are in touch. But I agree that something, specifically with HBCSE, I'm hopeful because I've been talking to Ravi and I understand he's might be seen in Bangalore. So I'm sure something will happen. Yeah.
Thank you. Thank you.
There are some questions which are actually chat.
In the chat.
Would you want me to kind of read up for you, or?
Okay, I think I can open the chat. So let's see. Rajesh, specific approach used for the physics lab courses. No, I have to say that these were really left to the individual instructors who came up with a lot of innovations. But I would not say that it was informed, as the term goes, by a specific theory of education, saying do this or don't do that or this works. So I think it was more learning by doing, right? But yes, in terms of ensuring that it was linked, since the labs, every lab is linked with the corresponding course and takes place, it's part of that course, it's credited along with the course. So we did try to link things to that. The very first lab course was interesting because students do come in, full of all the ultra modern things. And then if you just give them a simple pendulum and ask them to count, you may lose their interest. So I think my colleague Richard Fernandez actually came up with a very innovative first lab course. It's called Introduction to Physics 1, where on the one hand, it's something they can do, but maybe you spread oil on water and find out Avogadro's number or something like that. So things which are interesting. So, so Rajesh, if you meant some kind of formal structure, not yet, but perhaps you had something else in mind.
Yeah, probably Rajesh can ask on the. Yeah, he's on the Zoom. Rajesh, you want to ask?
No, Satya. I will speak to Rajaram a little later, maybe.
Okay, sure. We know each other for long, so surely.
Yeah, okay. There is also a question from Jay Kumar.
Yes, I saw that.
Okay.
Well, the fact of the matter is, I think that's also public domain, though maybe not widely known, that one of the drafting committee.
I'm sorry, Raja. I read this question because maybe for
yeah, sure. Does Azim Premji University, I should add, not the individual, have an official position on the NEP based on its experience on the ground? So what I was going to say was, I'm almost sure, that our Vice Chancellor, Anurag Bihar, was a member of a drafting committee which was convened by Kasturi Rangan, right? So, so I guess some of the it almost went the other way. Some of the ground experience might have been written into the NEP, right? So no, there is no official position. But interestingly, the foundation at the university have a very strong principle that you don't confront the government. You have a constitution, and there's a government electing according to that constitution, and within reason, you try to work within that framework. Okay. So even the design of the 4-year program, which is going on right now, is based on broadly on that. But the NEP itself is somewhat flexible, open to interpretation. So simple answer is no.
Okay. So there is also a comment followed by a question from Suravi.
Yes.
The question is towards the end, and of course, the beginning was appreciative of your lecture. So do you want to again read?
Is this the one which says, given APU's vision was to develop well-qualified professionals?
No.
Not that one. Okay.
Little above.
Oh, okay, sure. Yeah, research on the environmental science curriculum, right? Okay. So this is very timely because how universities can work up to.
So the question is.
Yeah. I realize. This is hard, right? We discuss a lot of the fact that on the one hand, we do give people degrees, and people should take those degrees seriously, and everyone has a mark sheet. But at the same time, the mark sheet shouldn't be the goal, right? It's a very difficult. I would not say how it's done, and I'm not even sure we have completely eliminated it, right? Because students are also subject to pressures from the larger society. But the most I would say is that we try to provide alternatives, right? And certainly the instructor doesn't only focus on the top of the class, right? So you really worry about everyone, and I think all my colleagues do that. So, so this broader question, I think one just has to be convinced that you have to do more than certify, assess and certify. Okay, so I hope that addresses Surabhi's question.
Yeah, there is one more question at the end by Arnab. If you can see.
Yeah, I can see that. So given that APU's vision was to develop well-qualified professionals in social sector, what fraction end up in this sector rather than just do physics, math, go down the standard career path? Okay. Since it's a question about the university as a whole, the postgraduate program is really the one where this vision was stated very explicitly upfront, but not necessarily, I should add, that the people should join the foundation, not at all. Some of them do, but I think here a very impressive fraction was. I've recently been reading a newsletter which sort of links with the alumni and so on. I would say it's a very good fraction in the postgraduate program, and in the undergraduate program, it's still too early. We've, as I said, graduated 3 batches, and there is also a lot of middle ground between the standard career, which is whatever the MSc, PhD, and so on, and ending up in an NGO, and many of the students do occupy that middle ground as well. I do see that.
Yeah, the reason I ask is because at the 12th standard level, when people are looking for universities in the sort of newer universities, Ashoka, Azim Premji, Kriya, there's sort of been this conception that Azim Premji is something which is great if you want to go into more of a social and humanities, that kind of thing, but may not be the best place if you wanted to do science, but it looks like the science syllabus is also very well thought of and very well designed. So is this just perception, or is it like too young, the university is really young and it's tough to say?
Well, I have to say, as I said, the total number of credits, we do not teach quantum field theory, which probably is taught in Presidency College, Kolkata, or something like that, right? Or in Delhi University. So in that sense, yes, if someone really wanted to hit the ground running and, focus, I myself would say, look at those places. They're not that easy to get into though, right? But, we, as I said, we're a drop in the ocean still, in spite of the scale and everything. So I think I would go along with the perception that there may be a certain kind of student who is not necessarily, the undergraduate program, we are not asking people to commit to anything, right? They can get a physics degree, and as I said, some of them, have gone on to go to even some of, the very good places and so on. And in bio as well. Bio has a very impressive record of placing people. So I would say I think for most students, if they're prepared, as I said, to look at the common curriculum, look at the interdisciplinary minor, look at we put that up front right in the beginning.
May I ask another question?
Mm-hmm.
So at APU undergrad, do you have to declare a major when you join in the first year, or are you allowed to switch majors sort of after realizing that, actually history seems a lot more interesting than I thought, or something like that, or physics seems what I really want to do?
See, in a 3-year program, we really could not do that. In spite of which, a couple of people tried. In that group photograph, there was one guy in the corner who ended up doing humanities. But in the early days, you can get away with things like that. But the system says, no, you do declare your major. Also because, the cutoffs and so on are a little different depending on which major you're entering into. So it will be a little unfair if we did that. Now, what happens in the 4-year regime is open. It's on the table, and I'm sure people are talking about it.
Great, thanks. It was fascinating to listen to you as usual.
I think Sushil was trying to ask a question.
Yeah, Rajaram, can I have a moment? Yeah. Yeah. So, I was wondering what kind of response do you see from the students as soon as they come into this new kind of a syllabus? I'm sure they're very well warned and they know what to expect. But do you see some sort of a surprise element taking over in the early few months, first semester or something?
Yes, and the problem I think is faced more by physics and maths than by biology, right? And I remember the very first biology batch which came in, the very first night they were there. You know, one of the faculty members took them out with a torch and showed them things that were fascinating. And biology has that ability. In physics, as I said, you know, they many of them come having a smattering of some very advanced theories and so on. And then we do see this disappointment when we say, okay, you can reach the theory, but here are the 5 previous steps which you have to take, right? So it takes a while. And maths, perhaps they face it even more because, you know, in the very first course, they are asked to go back to counting, right? So yes, it's very perceptive that we do face this. But I think with all the effort that the faculty puts in, hopefully they are kind of settled in, you know, before the first semester is over.
And at the end of the course, is there a feedback process from students so we know firsthand what they
at the end of every course, you get the feedback. Okay. Not just at the end of the whole course. Right.
Okay, thank you.
Okay. So, are there any questions from the Zoom participants to Rajaram? Okay. So I don't think there are any more questions left. So it's the time to thank again today's speaker for his wonderful and I would say thought-provoking also talk and also looking at a certain way. I mean, I'm not sure many of us know what this university is, why it is special, and as Arnav was mentioning, was it something, you know, has this perception or is really working towards a particular way of bringing up one aspect of it into the long-term perspective of this university, vis-a-vis the other ones which also came up around the same time. But it's very nice to kind of get a real ringside view, the way you also went in actually telling us the course curriculum and so on and so forth. And it's very nice to hear from you after a long time, but also on a topic which we were not so much of aware. Thank you very much.
Thank you, Satyanarayana, and thank you, everyone.
Thank you.
Thank you, Rajan. Thank you very much for a very nice talk, Rajan. Thank you.